I am Atir Maher, your module leader. It is my great pleasure to welcome you to the world of learning new concepts and current trends, so let's start. All right, welcome everyone to the guide for your SWE4304 database assignment 2. So, in the first assignment, you were the architect. You drew up the blueprint. Now you get to be the builder. We're going to go through step by step how to take that brilliant design of yours and build a real working database. So here's our game plan for today. We'll connect the dots from assignment 1, then get our hands dirty creating the database, show you how to prove it actually works, touch on some advanced features, and then wrap up with all the details on submission and your demo. Let's get you set up for success. Okay, first up, from blueprint to building. Before we even think about writing a single line of code, it's really important that we understand how that first assignment is the foundation for everything you're about to do. Just think of it like this. Assignment 1 was all about the design, right? You were the architect, creating the ERD, planning the schema, making sure everything was normalized. That was the blueprint. Assignment 2 is the construction phase. You're taking that exact blueprint and bringing it to life with actual SQL, and then, crucially, showing us that it works perfectly. Section 2, creating your database. Okay, now for the fun part, getting hands-on. We're moving away from theory and diving straight into practice, building out your database structure right inside MySQL Workbench. Your process here really boils down to 4 main steps. First, you're going to use DDL, that's Data Definition Language, to create your tables. Second, you'll add your constraints. These are the rules that keep your data clean and consistent. Third, just pop in some brief SQL comments to explain what you're doing. And last but not least, you need to add some realistic sample data, at least 5 rows for each table, because a database without data is just an empty box, right? And these constraints, they are the absolute heart and soul of a good database. Things like primary keys, foreign keys, making sure field is not null. They're not just suggestions. They are the essential rules that guarantee your data is accurate and reliable. They make your whole system work the way it's supposed to. Okay, section 3, proving it works. So you've built the database and you've filled it with data. Awesome. But you're not done yet. Now you have to prove it all works as expected. And for this assignment, evidence is everything. And this right here is the golden rule, so listen close. For every single task, you must show us 2 things: the SQL code you wrote and a screenshot of the result it gave you. If we don't see it executed, we can't say it's been demonstrated. It's really that simple. No proof, no marks. So what do you need to show us? Well, it's all the core stuff. You need to run several select queries that can pull specific data using joins and grouping. You also have to show you can manipulate the data. That means doing 1 update, 1 delete that's based on a date, and 1 insert for a new record. Basically, you're proving you've mastered the fundamentals. Section 4, Advanced Features. Okay, moving beyond the basics. Now we're talking about the features that take your database from a simple student project to something that feels more like a robust, real-world system. Let's get into security and automation. And let me be perfectly clear on this. These are requirements, not nice-to-haves. You need to create at least 1 view, which helps you control who sees what data. You'll need at least 1 procedure or trigger to handle automation. And you've got to set up a security model with different users and permissions. And remember, you need to show us the evidence for each one. Okay, section 5, we're on the home stretch. This is all about the logistics, what you need to submit, when the deadline is, and how to get ready for your in-class demo. Get your calendars out because here's the deadline, Sunday, the 25th of January, just before midnight. You'll be submitting 2 things on Canvas and Turnitin, a Word report, and a zip file with your SQL code. And just a friendly tip, keep an eye on your Turnitin score and try not to submit too many drafts. Now, this is a really critical rule. This assignment is category A. That means absolutely no generative AI tools. No ChatGPT, no Copilot, nothing like that for writing your code or your report. Your work must be 100% your own. A basic spell checker, that's fine, but that's it. In class, you'll be doing a short 10-minute live demo. Don't worry, it's just your chance to show off your work. You'll walk us through your database schema, explain the important constraints you set up, show us your sample data, and then run a couple of your complex queries live. And yeah, your tutor will ask a few questions, but it's just to confirm you really understand the work you've submitted. So a little practice beforehand will go a long way. All right, our final section, your roadmap to success. Let's pull everything together into a clear action plan and talk about what really separates a good submission from a great one. So what does success look like? Well, a fail is usually missing key parts, having code that doesn't run, or just not providing evidence. A pass is straightforward, a working database, all queries running with proof, and a solid report. But if you're aiming for top marks, we're looking for smart constraints, efficient queries, a thoughtful security setup, and a really clear, confident demo. So if you're wondering where to even begin, just follow this checklist in order. Implement your tables and constraints first, then add your realistic data. After that, test every single query and screenshot all the outputs. Now, step 5 is really important. Write your report and reflections. This isn't just about what challenges you faced. You also need to reflect on 2 huge database concepts, transactions and concurrency. A transaction is just a way to make sure a set of actions either all succeed or all fail together. Think about a Regent college enrollment. The system has to both register you as a student and assign you to a course. A transaction ensures you don't end up with one but not the other. Concurrency is about making sure multiple people can use the database at once without messing up each other's work. You need to explain why these are so vital for data integrity. And finally, don't forget your tools declaration and reference list. Then rehearse that demo. This is your path. So, right before you're ready to submit, I want you to ask yourself one final question. Look at your report and all your screenshots and ask, is my evidence so clear and so strong that it proves my work all by itself without me needing to be there to explain anything? If the answer is a confident yes, then you are ready to go. Good luck with the assignment, everyone. And remember, all the nitty-gritty details are in the official guidance documents on Canvas, so be sure to read those carefully. The contents of this video were put together by your database module leader, Athir Mahar. We are all really looking forward to seeing the fantastic work you produce.